Good morning. Um, this is episode 2 of LeetCode Path to Pro. Today, I'm going to be solving the second easy problem in the list if you just go sequentially through the problem list in LeetCode. Number 9, palindrome number. Palindrome number. I like this question because it's pretty straightforward, and there's not a lot of lines of code involved. So yeah, let's get started. So the question is, given an integer x, return true if x is a palindrome and false otherwise. So a palindrome is just something that reads the same back to front. So in terms of words, it's a palindrome. You'd have something like boob, B-O-O-B, that's a palindrome. But this is asking about numbers, so if we look at the first example, 121, that's a palindrome, because if you go 1, 2, 1, or you can go from the back 1, 2, 1, so it's the same. Here, the second example, we have 1, 2, 1 again, but it's a negative. There's a negative in front, and so it's not true, because if you read left to right, it's negative 1, 2, 1. From right to left, it's 1, 2, 1, negative. Same here with the example 3. X equals 10. That's not true, because if you read left to right, it's 1, 0, and right to left, it is 0, 1. So it's not a palindrome. So looking at example 2, we can see that if x is a negative, it's not going to be a palindrome, no matter what. So we can just take care of that case. So if we say if x less than 0, return false. Because it's not going to be a palindrome. And that's what they want us to do, right? Yeah, false. All right. So now, how do we check for if a problem is, or a number is a palindrome? We're gonna need, we do it like this: reverse equals 0, and we set this number, the original number. So we're basically gonna reverse x and set that as a new variable, and then we can compare x to the reversed x that we made. Yeah. So we'll say while x is, number is greater than 0, because this is how we're gonna reverse. And I actually had to look this up, but it's a super neat solution here that just reverses numbers. Super interesting way. So what we're going to do is digit equals number. What's the correct term for that? Percent? What's that? Modulus, the modulus operator. So this returns the remainder. And I'll explain kind of how that works here in a second. So digit equals number, and then we're going to do reverse times 10 plus digit that we just calculated, and then we need to increment the number down, right? Yeah, I got a note. And I think we're done. We're going to return there's a cooler return statement you can do here. Boolean return statement. Python. No. Do this. Let's see. Anything else? No. It's super simple. Return true. Yeah, we could do it like that. Return true, return false. But there's an easier way. I think it's like a easy. Turn to monkey. Let's see. Huh. Let's move it over. Well, okay. So we know. I think it's like you return x. So this is basically, yeah. So this is basically saying this return statement, return x equals reverse. So this is basically saying return true if x equals reverse, if x equals reverse, or it'll return false if that's not true. And so how this while loop is working is basically we're setting the digit. So let's say we have a number. Let's see if I can use the drawing pad here. Let's say we have a number like 4. That's a box. 4. Okay. 4. Can't do a 3. Not allowed. 432. Haha, that's horrible. So first, what we're going to do is we're going to set the digit to the number modulus operated by 10. So remember number, we set number to x. So number is 432. So we're percent divided by 10. So 432 divided by 10 is 43.2. But really that's modulus divide, it's 430, remainder of 2, right? And so that's what its digit is going to be set to, right? Its digit is going to be set to 2. Then we're doing reverse equals reverse times 10. So we set reverse to 0 to start. So reverse times 10 is 0. So 0 times 10 is 0 plus digit. So reverse is 2. So reverse is 2. And then we're actually dividing the number by 10. So now we're going to, this is no longer the number. What's 432 divided by 10? It's 43.2. Okay, so then we're modulus dividing again. I mean, really, we can drop the 2.2. It's going to make it more difficult to do the math in my head here. So 430% divided by 10 is 10, or is 4, times 10 is 40, remainder of 3. So we're going to set the digit to 3 this time. So reverse equals reverse times 10. And if you remember, do we have to increment the reverse? Wait. Oh, reverse was 2 last time. So 2 times 10 is 20. Plus the digit. So we're right, reverse equals reverse. So reverse, we set it to 2 last time. Because remember the digit was 2. Reverse times 10 is 20. Plus the new digit is 23. So now reverse is 23. And we're going to divide the number by 10. So now we have 4.3. But remember, you can just drop 0.3. Because we're minus dividing, it's not going to matter, you know, might just divide only once. Whole numbers, or what is it, whole numbers? Integers. I don't know what's the correct term for, you know, not a fraction. Whatever. The remainder is dividing 4 by 10. It's the remainder is 4. You can't divide 4 by 10. So remainder, it's 0. The answer is, you know, 0, remainder 4. Then we're setting reverse equals reverse times 10. So if you remember, reverse is 23. 23 times 10 is 230, plus the new digit, which is 4. So we have 234. Can I just drag this? Haha, nice. And then we're dividing the number again. 4 divided by 10. Is going to be a small number. It's going here. This is indented weird. Yeah, 4 divided by 10 is going to be a really small number. What the heck's going on? Oh, this is the issue. Cool. Okay, yes, I don't know. Indentation was weird. But yeah, 4. So right, we're keep going. 4 divided by 10 is going to be a really small number. And our while loop is going to exit. Well, it's not going to exit. It's just going to get smaller and smaller. Maybe the division is just going to set it to 0. 4 divided by 10, because it rounds down. That's probably what happens, right? So this divide, it takes 4 divided by 10. And, you know, that's 0.4, I think. Something like that, right? 10. And then it's just going to round that down to 0. So number is no longer greater than 0. It's going to exit. And then we're going to go to this. And our new reverse is 234. And x is, if you remember, x is 432. So equal. I don't know, I'm explaining that wrong somewhere. That doesn't make sense. But I have to go to work, so that's going to be it. Yeah. So what's the runtime of this? I think it's O of n. Right? Because we're going through each digit in n. Yeah, let's see if somebody, I'm pretty sure. In one line. What's that wizardry? Okay, well, yeah, I'm pretty sure it's a win. Thanks, y'all. Bye. There we go.